So what we're going to work on today is more with the irrational and rational numbers. So what we're going to talk about is how to convert these repeating decimals into their fractional equivalents. Okay? And you're going to see there's going to be two different ways we're going to do this. And one is obviously going to be much easier than the other. Now, we talked about yesterday, for a decimal to be a repeating decimal, what has to be true about its denominator? It has to be a prime factor other than 2 or 5. Okay? Now, one of the things to understand is that, or one of the reasons we do this is we don't like to deal with repeating decimals. And the reason is if I ask you to do 0.3 times 6, that's a mess because this 0.3 goes on forever. But if you knew that what you really were doing is 1/3 times 6, you got a nice simple answer of 2. So that's why fractions are always preferable to decimal equivalents when you're dealing with repeating decimals. Now, what you're going to do, you're doing this with your calculator, is you're going to convert each of these fractions into their decimal equivalent. So you've got 0.2, 0.7, 0.13, 0.25, and again, it could be written a couple of different ways. 0.248, 0.723. So what do you see is happening here? Well, hopefully you've noticed that if the denominator is 9, then I have a single repeating digit. So rational numbers with a denominator of 9 repeat a single digit. Okay? If the denominator is 99, then 2 digits repeat. If the denominator is 999, then 3 digits repeat. I'll add the word repeat here. And the pattern continues, no matter how many places we go out. Okay? So, what we can do is we can convert numbers into their decimal equivalent, or these fractions into their decimal equivalent. Okay? So, what we can do here is take 13 over 999. I need 3 places because it's 999. So you get 0.013 based upon that rule. Now, how would I convert 285714 into its fractional equivalent? Well, that's what's repeating, which is 6 places. It's 285714 over 6 nines. Okay? Now, I would not give you a number this large without a calculator, but you'll see that that simplifies to 2/7. All right? The thing you're always going to look for is you always want to divide by 3 or 9, the numerator, because you know the denominator is divided by 3 and 9. Now, I want to show you how we do this using two different methods, which is algebraically and then what I'll call our shortcut. So I'm going to divide this into two parts. To convert 0.4 into its decimal equivalent, all right? Well, it's repeating only the 4. So 4 is repeating, it's one digit repeating, it's just 4 over 9. It's as straightforward as that. Now, how does this work algebraically? And this is why the shortcut rule works, so that's why I'm showing it to you. What we do is we say let x equal a repeating number. Now, since it's to the 10th place, I'm going to multiply by 10. So 10 times x is 10x, and 10 times 0.4 is 4.4, repeating. Just move it over one decimal place. I subtract what x is, which is my 0.4 repeating. So when I subtract this, 10x minus x is 9x. 4.4 repeating minus 0.4 repeating is 4. Divided by 9, and I'm done. Obviously, what I did on the left side is much simpler, okay? But I just want to make sure you understand why the shortcut works. So let's do the next one. I want to do 0.27 as its fractional equivalent. Well, 0.27 is going to be equal to 27 over 99. Both of them are divided by 9, so it simplifies to 3/11. Okay? Algebraically, let x equal 0.27, multiply by 10. Now I'm going to multiply by 100, because it's two decimal places. See, if I multiply by 10, all I'm going to get is 2.7, like that. And that's not good, because I don't have my full repeating. Or the other way to look at it is 10/100ths place. I'm going to subtract my repeating part. So I get 99x equals 27. X is 27 over 99, which simplifies to 3/11. Okay? So what we covered today were two ways to convert repeating decimals into their fractional equivalents. One way is algebraically, the other is what I would call the shortcut method. Either one of them is fine to use. I'm assuming most people use the shortcut, but it's always good to understand mathematically why something works the way it does.